welcome back. Welcome back to our XTrawAI podcast series. And today I have the pleasure of talking with Mr. Aamir Siddiqui, co-founder and CEO of OrangePro AI. And we are going to talk about an interesting topic. So we're titling this episode something like Two Instruments, One Code Base. When I talk about it, frontier models and deterministic software risk, how they map. So welcome on board, Aamir.
Thank you, Raghu, for inviting me. Appreciate that.
So a brief background about Aamir. Our guest Aamir, he's the co-founder and CEO of OrangePro AI, as I've just mentioned. Aamir and his team are building an independent quality layer that maps software behaviors, flows, test gaps, and risk across a code base. We'll talk about this a bit in our conversation. In a recent public experiment, they ran Cloud Fable 5 and OrangePro MCP against the same open source production repository, 20 CRM. The two tools, when examined, the same target through completely different lenses, and their findings barely overlap. So this is one of the things I wanted to touch base on today's conversation. So this is a little bit background about Aamir. So before we get started, Aamir, I want to first start with a brief personal or a professional backstory about how you ended up doing what you are doing right now when you're at the intersection of AI, software testing, and quality and engineering quality. Maybe a background about this.
Thank you, Raghu. I am basically an engineer by profession and spent almost 20 years in engineering and quality assurance. Places like Salesforce, ServiceNow, Oracle, Autonomic, which was acquired by Ford back in 2018. In most of these big tech companies, I was responsible for release quality on the platform. Maybe in ServiceNow case, serving around 120,000 customers, B2B SaaS customers, 500 million transactions a week. So, I have seen these big systems. That's what my main focus has been for the last many years. The thing is that kept happening whenever I was an engineer, before I moved to in the leadership position, that we would have massive QA budgets, multiple layers of testing, and critical bugs would still escape to production. Not because people weren't working hard, actually because nobody owned the system as a whole. So the PM owned the spec, the dev owned the code or the source code, the tester owned the test cases, but nobody owned the system. So I built OrangePro. It's a structural layer that is, in my opinion, missing. It maps every behavior in the code base, scores how exposed one is, and tells you exactly where your blind spots are before your user find them. And then just to kind of fast forward it, 2024, 25, when the LLM arrive in the workflow, and the same patterns set up again, but even worse now, because now the same system writes the code as well. Reviews the code and writes the test for the code as well. So the author is grading this own work, if I would say. And so co-edited reviewers don't catch co-edited mistakes, right? The amount of errors that can potentially be made in production is exponentially higher now.
Beautiful. I think that's a great piece of background and a great journey working with you're an engineer turned founder, a co-founder, and working on a very important aspect of quality and quality layer. So I would like to get into this, understand a bit more about your experiment. I know, why did you, maybe I'll put forward this one. Your comparison when you talked about I think this is where you're saying that it almost provided no overlap between the Claude Fable 5 and OrangePro. Did it surprise you, and what did it immediately reveal about how these two instruments see software? So because this is a big question, right?
Yeah, no. So the short answer is no, it doesn't surprise me because that's the whole point of having this experience.
Mhm.
In the experiment was kind of make showing that, I mean, I was more surprised if it would actually more
Mhm.
than overlap more than what I would expect. So what happened is a bit of a teaser for you guys is that, we pulled both outputs side by side, Fable. So we ran Fable on both like 20 CRM, which is probably one of the highest rated, star rated GitHub repo for CRM, like alternate to Salesforce. So
Mhm.
we pulled both outputs side by side. Fable had found a JWT key rotation base that only fires in multi-replica deployments.
Mhm.
Brilliant, right? You
Mhm.
know, you found that by reading the code closely and tracing logic across files. So, as if you basically are dev and doing a code review kind of thing, right? So,
Mhm.
but no graph surface that. That's the point, right, of Fable, right? So, then our output, the workspace migration orchestration cluster took four of our, top nine slots.
Mhm.
The code files Fable never opened.
Mhm.
Those are the files which Fable never even touched. So the whole
Mhm.
family whose risk is concentrated um, orchestration depth, right? They are invisible unless you map everything. So basically, what we are doing is we are sort of mapping the whole code base in such a way that unless you unmap it or sort of unpack it, there is no way you can find those issues. So we have a near zero overlap. We have some overlap, and that's the
Mhm.
point. So the analogy, I would say, maybe, it might sort of makes it easy to understand is X-ray and MRI. Same patient, completely different images, both clinically necessary, but nobody argues about which one is better, right? Because we are basically serving sort of a different purposes within the software development lifecycle. Um, Fable finds how something will break and
Mhm.
the mechanism, right? How would it actually? So predicting sort of failures, if we can say. I mean, we find what's untested and
Okay.
exposed.
Mhm.
So which are the blind spots, right? Which it's you can say unknown, right? I mean, you may have
Mhm.
seen the quadratic equation of known, unknown, known, unknown,
Yeah.
known, all that. So you need both. And
Mhm.
you know what? Unfortunately, most teams have neither.
Right. So that's a great way of putting that together, Amir. I like the way the analogy that you put. Both are needed. An X-ray machine is needed, an MRI is needed for the patient to diagnose. Uh, Meaning the problem, I think it's a problem stage. I think what you're trying to understand. Like you said, I think with the Fable 5, I think it understood where things are breaking. But the problem is that in some scenarios, you don't even know what you don't even know. So that is where I think, which is where you're trying to address. But before going into my other question, before going further into this, I have uh, a question for you. For listeners who think primarily in the type in the context of like files, functions, and test coverage, what exactly is a behavior in Orange Pro? And how does a behavior graph reveal risk that a conventional code review or a uh, coverage dashboard may miss or may not even completely even touch it? Could you speak a bit about that?
Yeah, so I think one of the key things we have to understand is, what is the behavior, right? I think that's what you're
Mhm.
asking. The two labels, we have two labels, and it's distinction that matters, right? So
Mhm.
behavior is a public method in your code that has an observable outcome, something a caller can depend on,
Mhm.
not a line, not a file. So I think the fundamental question before that is that why 20 CRM, right? Why we actually chose one,
Yeah, yeah.
not the other one? And one of the key things is that it has 24,000 files, 51
Mm.
stars, and 140 plus server modules. So it's a real production system, real users, real bugs in a very public sort of a setting, right? It's an open source project.
Mhm.
So nobody can say that we cherry picked a toy repo or anyone kind of listening can rerun it.
Mm.
So So the design was hands off. Same repository, same commit. Fable reads about 75 files. It selected itself, and Vision about semantics, and VMAC scored every behavior around 5,000 of these from the code base. So no coordination, no tuning, no hints, right?
Mm.
Then he asked three questions. So, where do we agree? Where do we disagree? And when they disagree, who is the right? Who is the right person? Who is the right tool for us to kind of get the final word?
Mhm.
Um, so coming back to the behavior thing, right? As
Mhm.
you see, behavior is a public method in any code.
Mhm.
20 CRM has about 5,000 of them. And
Right.
the flow is what happens when a real request hits your system.
Mhm.
The sequence of methods that actually execute along the way, connected as a call chain. So there are about 500 of those. And we only sort of selectively show the 500. There may be more or less. Uh, but that is something that we just want to do like more like on a free MCP version.
Mhm.
Um, we have this solid lines, if you look at the report there, and I can send over the report as well. Um, the solid lines where the code calls the code calls the code directly,
Mhm.
and the dash are where the framework wires it together. So a queue, a processor, and a route handler, or something like.
Mhm.
So the part that most developers in QA will find it useful is sort of a color scheme. So each behavior is colored by how well it's tested. So the sort of green means a test proves it breaks if you change. Amber means a test touches it. The test touches it. We found the test, but it never proves the breakage.
Mhm.
And red means nothing tests at all.
Mm.
And most of the coverage dashboards I see so far do not make that distinction because there is no way they can make that distinction without a deterministic knowledge graph. They only know a line is executed. So you can
Mhm.
sit at a 90% coverage with the red chain running straight through the middle of your product. So one concrete example I can say, is on 20 repo. The flow where a user creates a workspace and invites a teammate, process the workspace service, the user service, notification, authentication, permissions, almost four subsystems. Every file green on the dashboard.
Mhm.
Literally, every service was green,
Right.
but
Right.
nobody had proven the journey. So, you know, so just to kind of close down on this, each behavior has edges to the code that implements it and the test that links to it. So this is mostly the end-to-end test coverage, right? Systems are really good in doing the unit testing coverage, but they're really, really bad in doing the end-to-end behavioral coverage. Um, and the MCP is free, local tool, the code test dependencies, incident history requirements, what our platform adds on top. So the
Mhm.
worth knowing is that because the migration finding I will get uh, to come from the structure alone, the tool had no incident data at all. Even
Mhm.
then, it actually identified those 500 flows and behaviors which are lacking test cases. So that's the value that the MCP graph have uh, today.
Right. Right. Beautiful. I think I like the aspect about unit testing compared to a complete end-to-end test coverage. And here, while some of the tools out there do not even provide you all these different kinds of test coverage, or whether a particular aspect has been covered, whether particular aspect is broken, or whether a particular aspect has not even touched upon. So these kind of variations you show. So I want to get into this question about the tools agree exactly twice, right? I think both flagged and the message queue layer,
Yeah,
where you're talking about 184 importers dependent on one particular specification,
yeah.
and both rank the page layout, the page layout family near the bottom of it. But why are those two agreements so meaningful? Uh, could you elaborate a bit more on that before we get into the actual enterprise quality problem where I want to talk?
Yeah, that's where one of the very few cases where we agree with each other,
Hmm.
because when two fundamentally different methods independently converge,
Hmm.
that's the strongest signal you get. So So the alarm is that, we ranked it 18th. 184 things imported it and had one test file. Fable independently put it in tier 0. It does not
Okay.
see uh, you know, uh, the sort of a graph that we have made at the back end, right? So it looks at from a very different lens, you can say, right? So different method with the same conclusion. The page layout family, we put it 20th. Fable words were sort of correct to deprioritize. Both independently said, um, don't worry about this one. And this is
Mm.
where we agree on it. So converging on what not to worry about is as much harder to fake than converging on alarms. Nobody manufactures agreements on what's boring, right? But when your team has limited hours, and I've seen this so many times in my corporate jobs, is you just do not have the time to ship the product, and most of the times teams are building or working on things that honestly do not matter
Mhm.
uh, in the final sort of shipping the product thing. Um, so knowing where not to look is worth as much as knowing where to look. And that's the whole point of not just uncovering the unknown unknowns, but also, I would say, prioritize the knowns also, or deprioritize the knowns as well, so that the team can actually focus on things that matters and not and not running 10,000 test cases that probably have not much of a value when it's shipping to the product.
Beautiful. I think I like the way you put it, like deprioritize some of the known problems because you already know about it, and then focus on those unknown unknowns. And then that is how you can bring that in. Let me get into the uh, topic a bit more deeper into this enterprise quality problem, right? You also come from this huge corporate background. I think you briefly mentioned uh, initially saying that this now we have these AI coding agents that can produce and modify software much faster, like than people can even review it, or even the organizations can review it. What is that business risk when code velocity increases, but the organization's ability to understand the behavior or the dependencies, the test gap that does not exist or does not uh, the gap is not there. So what's your take on that?
Right. So this shift happens pretty recently, right? I mean, when
Mm-hmm.
the LLM comes around and the coding agents becomes more mature, and I honestly also do a lot of these using those AI coding tools like Codex, Cursor, and Cloud Code. And they are really, really good, right, in what they do. So code is becoming cheap,
Mm.
honestly. Like you can see that, when sort of uh, if you want to build or re-architect the whole system, previously it takes weeks or months, right? And you have to hire a developer. Now over a weekend you can easily do it. It will scrap all the old code and rebuild everything from scratch. No issues. But the problem happens, the bottleneck shifted from the coding speed to the QA, because who is going to test those artifacts reliably in a way that your customers won't get, you don't get a customer churn or production issues, because you will then spending more time fixing those issues than perhaps the time you spend in building those products. So when the agents generate and, I would say, modify the code at speed, humans lose track of what actually shifted. The question becomes, what do you run continuously to know where the gaps are? So code ships faster than any team can review it. But QA didn't change, actually, unfortunately. So the same testers, same manual reviews, same regression suite. Or if you say, just, even the QA is actually depending on the same AI coding agent that develops the code in the first place, and
Mm-hmm.
asking them to kind of find the issues. It's like having the cake and eat it too, right? You just can't do it.
Right.
You need a third party auditor. So every PR that merges without the behavior validation is a bet. Um, most payoff, I would say, but the ones that don't cost orders of magnitude more than catching them would have.
Mm-hmm.
So, the one of the key AI era danger is that the correlated failures.
Mm.
So when the same model, as I mentioned earlier, right, the same model writes the code and writes the test and reviews the PR, you have a single point of reasoning, a single point of failure. It's one person writing the exam, setting it and grading it, I would say.
Right. Right.
Perfect score every time,
Right.
and but you have proven nothing. So the current way of AI testing tools really does not fix this. They
Mm.
generate more UI scripts, click here, click there, type here, assert that. But most tests do not have the business context understanding. You know, you have to have test cases um, that have the better quality understanding of your entire system end to end. But if you're testing the wrong things, then even 1,000 scripts won't work. But it will give you an illusion that you have tested enough. But you can still miss the chain that processed 3 services or 4 services or many services along the way.
Right. Right. You raised a great point and very important point, right? I think, for example, like you cannot give your own test and you cannot correct it and you cannot validate it yourself. So that is what is happening now with this, the speed of AI coding agents producing the code, and also some of these agents also developing or these QA, these UI scripts to do the testing and all. I believe your post also contrasts a probabilistic reader with a deterministic ranking system, right? Where
Yeah.
does where does this repeatability become essential for an enterprise? For example, in pull-in requests or this pull request gates or audits or regulated environments, so on and so forth. What's your take on that?
So it's really simple, right? I mean, think of any LLM, ask the same question again with the space of 5 minutes, you would get a different answer. So the
Mm.
stochastic nature of any LLM makes it's a good thing and it's a bad thing also because throughout the sort of history of testing, we never have that issue. Expected result is always equal to asserted result, right? I
Yes.
mean, the output was always the same. So now you can create thousands of test cases, run it against or regress it against a new release, and everything works. But now, picture this scenario, right? A production incident.
Mm.
Your CEO in the room, how did this get through, right? Or your VP of quality engineering or whatnot. And what was our process? He was asking the same question. So if the answer is we ran a model on the PR
Mm-hmm.
and it said it looked fine, the next
Mm-hmm.
question, the next question is run it again.
Mm-hmm.
And if it comes back different, you will literally have lost the room because now the test might fail the next
Yeah.
time.
Yeah.
So this is not a quality gate, right? That's a coin flipping with hoping for the best, right? With good vibes.
Mm-hmm.
So in practice, ask a model the same question twice and you get two reasonably slightly different answers. Fine for a conversation, useless for a rule that blocks a release, right? You cannot just gate your release based on that sort of a coin flipping thing. So
Mm-hmm.
the alternative is, I would say concretely, is same input, same ranking every time, set a threshold, audit it, show the evidence trail. SOC 2, HIPAA, PCI auditors want a trace from requirement to the test to results. Deterministic system produce that trace, right? That's the main thing. And I've done this
Yes.
exercise in multiple companies where, this is the one of the key things that, all these auditors ask that give me the traceability from end to end.
Mm-hmm. Mm-hmm.
So I'm not saying the model are useless. They are brilliant for depth, deterministic for gates, because gates must be repeatable. Probabilistic for the deep dives because those need semantic understanding. Different instruments, different jobs.
Mm-hmm.
The boundary that makes you credible is, I would say, there's one caveat that I would insist is the map is deterministic. The tests, the tests to test a model writes on top of it are not. So, which is
Mm-hmm.
exactly why nothing no a model writes gets trusted until we execute it and try and break it. So the underlying layer, the foundational layer of your system has to be deterministic.
Mm-hmm.
And you cannot just use, without which you can use LLM as a probabilistic layer. that can work in most cases, but when it actually goes wrong, it actually really goes wrong. And the cost that it will give, the cost to fix those issues is enormous, because the blast radius is now much more than it used to be when only humans are coding, and there are the finite amount of PRs going into production.
Right. I think it's a great way of putting that across. When only humans were coding, it is different. But now with agents as well coding, I think the blast radius significantly increases. And like that particular deterministic trace from input to output, and how do we get that? It's going to be very important. I want to get into this aspect of Orange Pro. I think you folks placed the workplace migration cluster in 3 of its top 10 risk positions. So could you elaborate on that and what it is and why uh, the logic behind it?
Yeah, this is my favorite finding actually.
Mhm.
But the first thing I published about the repo I got wrong. So let me, and that's why I trust the second part. So I published a correlation, a service at the top of our risk list with a real production bug in it. And
Mhm.
then we pointed the model at our own scoring engine, and it found the defect that had inflated that service. So we are
Mhm.
counting a test that merely had a similar name as though it was a real evidence. So my correlation was an artifact of my own bug. We withdrew it publicly and fixed the score at the same day. So it's all in the commit history that you can see in our MCP, sort of MCP project on GitHub. It's open source. After every one of those fixes, the one thing that stayed put is the workspace migration cluster. 4 of the top 9 slots, and at that point, we still hadn't looked at the issue tracker. So I went and looked, 5 public upgrade failures in June and July only. There
Mhm.
were aborts, timeouts, user logged out after upgrading the exact cluster the graph had at the top of the list. So OrangePro never saw the bug reports before, right? Before running the analysis. It only
Mhm.
reached the graph. Um, so why we did it, right? Because sort of the high fan out cross service boundaries, concentrated orchestration depths, thin test evidence relative to how central it is, structure anticipates where the failure lands. I'm not claiming we predicted those specific bugs, but they were already filed, right? I'm saying that you don't have to wait for the incident to know where the risk lives. So that's why we deliberately don't want to read the issue tracker history before running the report itself. So it's an intuition the senior engineer develops after many, many years, right?
Mhm.
Um, like don't touch the migration path on a Friday evening. We encode that on day one without needing the 2 years of tribal knowledge. And that's the powerful thing to have, because now, people are kind of moving away from manual QA, and they're moving to more towards autonomous QA, right? We are still there's a lot of things to happen before we can get to that point, but things are very clear. QA is changing, and they want the same set of speed in the QA as we have today in the code generation. We can't achieve that, or we can't cross the chasm, right, until we have some solid deterministic way that updates regularly with every change, but gives you exactly where the gaps are. And that's exactly what we have done with this migration thing.
Beautiful, beautiful. So with this, the approach that you guys are using is that how can I find out those unknown unknowns using the migration paths? I think the code that you made was also very important, right? I think because earlier there was always this scare factor about doing or starting a migration job over a weekend or before Friday. So that is one thing you're trying to address. So let me get into maybe if you could walk us through an example or a practical Orange Pro MCP workflow example uh, that could highlight. We don't need to talk about the for the public for the confidentiality information. We don't need to know or talk about the customer names or scenarios. But if you can walk us through an example how this it look like with Orange Pro. It'll be helpful.
Yeah, it's really simple. If you know, it's if you have a repo, right, you install the MCP server locally,
Mm-hmm.
point it to a repo, either private repo or public repo. The good thing is nothing leaves the machine, so there is no key needed for the scan. You bring your own model key if you really want to generate the test cases, but for the graph creation, no key is needed. It's all software. It's all in the code also. So you can, all is open source. So you can look at in GitHub, go through the code if you're interested. So
Mm-hmm.
basically, you can install your MCP server from npx, and then what happens once you run it, it takes around, probably depending on the size of your code, anything between 30 seconds to 5 minutes, right? Depending on if you have a huge code base.
Mm-hmm.
So what it maps is every public behavior, the call chains they form, the test links, the dependencies, and what it scores is the structural exposure. So, let's say dependency, fan out, churn, entry point position, data sensitivity, test evidence, and what it produces is a ranked risk list, and the
Mm-hmm.
priority gaps. So
Mm-hmm.
separate work list of unproven behaviors. So let's say if you identify 10 behaviors right across the board, and two of them can be proven by the test cases that you have, and the eight of them are not, that's your gap.
Mm-hmm.
Um, and the report is really, really careful about that distinction. The priority gap is a work list, not a coverage percentage, right?
Mm-hmm. Mm-hmm.
That often see in most of the tools. So we keep them apart deliberately, because the moment you turn it into a percentage, people start optimizing the number instead of the risk.
Right. Right. Yeah.
So the property that makes it a gate, right, is the byte identical across runs. Same commit, same output every time. It does not matter how many times you run it. It's the same, because at the at the at the fo- in the background you have the deterministic graph that is updating in real time. So if there is no update, it will not flag things out of hallucination
Mm-hmm.
just to give you something. It
Mm-hmm.
will, I don't have anything. It's the same thing. So which means you can diff in between, you can make a diff in between commits, trend it over releases, which is an important thing in enterprise. If you don't have a trail of evidence in the last like couple of months, how your code evolved, there is nothing you can do. If you can't improve what you can't measure, right? And you
Mm-hmm.
have to measure it reliably.
Mm-hmm.
So, basically the operating model that we have is run it on every change, every PR, pull request. It costs nothing if you're not using LLM. If you're
Mm-hmm.
using your own LLM, it actually costs cents.
Mm-hmm.
But you may be using Fable at some point or some other coding tools, right? So that's why I'm trying to give a bit of an idea that how this our tool plays well with any other frontier model is that we, instead of sending 10 MB of data to a Fable, and then you run into a issue of hallucination, we are the ones who actually sit at the bottom, give you the only the two things or the two high risk thing by prioritizing all the behaviors to send it to Fable.
Okay.
And then Fable can take those smaller input, less hallucination with the broader context, and give you the final good test cases if you want to, or something like any cloud code or codex or cursor. So that's the whole point. You can save your costs by
Mm-hmm.
just not dumping everything on LLM and asking them to figure it out, which it's not meant for. And when it flags something, that's your signal to spend expensive model attention there, and not against the whole code base.
Right. I think that's a very interesting point that you made, right? Because in this age of tokenomics and tokens being uh, used, and I think every firm is now getting into that problem, right? I think initially it was like, hey, go ahead and start using the tokens and make it work, or try to, and now there is already a lot of budget control on that. So now
Yeah.
you come in the space between you still use Fable or Mythos? No, not Mythos. I think Mythos is still open. Fable or other like Codex or other things, but you sit in between saying that okay, you can still use that, but now identify those. Orange Pro will help you identify those key risks, maybe two or three which you identify, and then now you use your tool, whether it is Fable or other things. And then how you're doing, you're trying to make it using a deterministic graph in the background. You're trying to map the structural exposures with your risk ranking and so on and so forth. And that's how beautifully you've laid out. I would I know you've earlier you made a statement like I think one of the interesting parts of your experiment uh, is that Fable's top defect existed in Orange Pro's candidate tier, but it did not reach the top 20. Tracing the disagreement exposed two missing scoring factors, and also you uncovered a flaw in your own scorer or something like that. How do you turn that kind of a disagreement into a better methodology?
Yeah, I mean, this is all something which is an ongoing way to understand the sort of different tools, how they react in different,
Right, right.
reports, different languages, and because it's a very diverse world of reports, the coding, right? Like
Mm,
software, and everybody have its own peculiar way of doing things, and lot of times that information is not in the code, right? It's in people's head.
mhm.
So, we would try not to do a one size fits all thing. That's the most important thing. So the disagreement as a diagnostic, as you mentioned, right? This is the part that I'm most proud of publishing, because it makes us look imperfect.
Mm.
You know, what was the gap? Let me just give you a bit of a
Yeah,
context, right?
yeah.
Um, Fable's top finding was the key rotation race.
Mm,
It was in our data at our candidate tier outside the top 20. So top 20 is our main, and outside of it is like candidate. Like they may or may not be, right? It's more like a review thing. So my first instinct was defensive, right? I mean, Fable's top finding, and we are not even showing it, right? Then I did the thing um, that I was supposed to do as a tester myself, right? Trained tester. So why it happened? So
right.
what it exposed is two factors. We had written in our own methodology and never shipped in the formula. So whether a failure is silent, a background job that dies quietly is worse than a page that visibly breaks, right? Because those are the one of the, I would say, example of unknown unknowns. Because nobody finds out for weeks. I mean, if something is bad on the page, right, anybody can see it and fix it. But if the background job dies quietly, it's really hard for anyone to know unless you have some sort of a observability mechanism. And who is affected? Auth and infrastructure code hurts everyone at once.
Right.
So most of these outages, if you look at the last 5 years, Microsoft, Cloudflare, big ones, cost
Mhm.
millions of dollars. They are all silent processes at the back
Yeah.
end that fails and nobody knows for
Until
sometimes
it happened. Yeah.
days, yeah, until it happens. And by the time it's too late, like I think Cloudflare happens recently, couple of times also in the last few years. So we want to expose those things more than anything else. And how do you do it? You cannot just rank everything the same. You have to
Mm,
have a deterministic graph at the back end, and then you do like risk profiling of each one of these things
mm.
using end-to-end scenarios, how important it is from the overall system standpoint. So what happened? So just to give you a bit of a context is, we have this methodology, but we never shipped it in the formula, right? So when
Mhm.
when a failure is silent like a background job, nobody knows who is affected. Um, so what happened is the other direction for us for the tool to catching the model is on the second repo, our tool asks a model to write a test.
Mm,
The model inserted a public error message. We ran it, it failed.
mm.
Because the model had invented a plausible sounding message, and that real one was sitting right there in the source. So we corrected the expected value from the code we ran, and mutation proved it. So disagreement between the instrument isn't the failure, it's a diagnostic. You see, when you actually use some like different LLM models, right? Not all LLM models are good in everything. So
Right.
sometimes you look at LLM like OpenAI for like say essay writing, but you use Claude for coding, right? Or Gemini for email writing, or something like this.
Right.
So our main understanding is, or learning from all that, is that disagreement between instrument isn't a failure, it's a diagnostic. And
Diagnostic.
here's what a deterministic tool buys you. When it's
Mhm.
wrong, you can prove that it's wrong.
Yeah. Yeah.
You trace exactly why it scored something low, fix the factor, and verify the fix. Try that something with any other LLM that samples differently with every run. You really can't catch it because it will say, oh, I forget about it. Let me just fix it. So, you always have to be one step ahead of any LLM
Yes.
tool to kind of understand what they are doing. In our case, our system bubbles all these things up the chain so that you don't have to guess anything, and it's sort of the same all the time whenever you kind of run it or rerun it.
Right. I think it's a great way of explanation that disagreement happens not because of the failure, but I think it's because of the diagnostic tool, that the diagnostic mechanism. And that is where here what you folks are doing is that you're mm, putting that all the trace across so that you understand that where and what and how it happened. Uh, I would like to, I know in the interest of time, I would like to go into this particular question. You summarized the operating model as Orange Pro on every pull or every pull request, and then spend a frontier model again on the top of that list. I
Yeah.
think, could you explain how that combined workflow should look like for any organization working on that?
So let's start with the layer one. So
Mm-hmm.
Honest Pro, on every pull request, every change that you're doing, it ingests your code, all your changes in real time.
Mm-hmm.
It can also see things beyond your code. Like, for instance, if you link it with your Jira or sort of linear, issue tracker product, we can ingest any new data or updates to any of your incidents, production incidents, or your stories or requirements. So we take it from there. So we frankly work all the time to keep our graph up to date. And whenever we find new data, we add it in our graph, so our graph is up to date. So now, every time that you are fixing a bug or shipping a new feature, you can run your Orange Pro to identify the gaps, right? Which costs you cents. It's a deterministic thing, it's CI gateable. So you have your continuous risk map.
Mm-hmm.
It's like a smoke detector in every room, something like this.
Okay.
Not where it's convenient for you to fix the smoke detector, but it has to be in every room because you just never know where the smoke starts in the first place. Layer two is the frontier attention against the top of that list, not the whole code base. So the model reads So the good thing about the model is that they read deeply and finds the mechanism no structural tool anticipates. Um, but pointed at the right target because the map already told you where. So, you know, think of Orange Pro as a map you have, right? And now you going towards that direction through a car. A car is your LLM. If your map is not correct, you will never be able to find a destination, right? Even though how good your car is. Does that make sense?
Beautiful, beautiful. I like the way you have put it. If the car is the LLM, Orange Pro is your map. So now comes to the interesting question. I termed this as the extra AI question. I know it took a while to come here. The $1 million or the $1 billion question. That's how I put it. We did talk about it, but I think, do you want to? What's the differentiation factor with Orange Pro AI? I know there are a lot of tools, a lot of competition out there, a lot of things running across. So how do you term this, Orange Pro? Is that what are the statement that you just made, or do you want to add something on top of that?
So just to, I think everyone else is trying to write better test cases. We are trying to answer a different question. What is in this system is unprotected, and how can you prove it? Nobody else in the category will give you a number that does not move. Um, let me just give you a bit of a context. Three things nobody else doing together. One, we enumerate every public behavior in the repo, not a sample. Two, the answer doesn't drift, right? Same commit, same version, same ranking, byte by byte, which means you can gate a merge on it and hand it on an auditor, and it's believable for the auditor also because he can ask you to run it again and you get the same output. And the three is that we refuse to call everything proven until we break the code on purpose and watch a test fail. So the category is full of tools that generate more test cases, more unit test cases, more UI test cases, click here and there, record and playback. We are not in that business. We tell you where the exposure is and then prove whether it's actually covered or not. So, you know, the honest answer is that our static analysis is in the mode. A good model can improvise most of that in an afternoon, right? Or in a day. One did against our own tool. What can't be copied by a better model is the position. So as AI writes more of the code, nobody has to verify it. Who is in the thing that wrote it? Nobody except an auditor employed by the company being audited. Labs aren't going to build that layer. It's not, even if they build it, nobody believes it, right? The incentive is to make the author better, not to independently grade the author. So every time model improve, our reading layer improves also for free. So our verification layer gets become more necessary. That symmetry is the differentiator. So everything else is implementations.
Beautiful. You laid it out very well. Thanks for joining us and having such a transparent look at both the strengths and the limitations of your own system, as well as how all these other models and how you can help OrangePro AI can help enterprises and firms. Before I let you go, what are the three most important takeaways that engineering leaders or AI builders have to remember while combining these frontier models with deterministic software risk mapping? Because we know that coding agents are becoming more autonomous over the next few years.
Yeah, I think it's really enticing, right, for most of the leadership to use AI coding agents to develop faster, have less developers, right? We have seen
Right,
these
right.
different things going on in the Bay Area and around the world. The thing is, you really have to build the culture of how you use AI than the tool itself. The tool always come and go, right? But you just the way the quality wasn't a culture like many years ago, right? 2 decades ago. Quality was always a second class citizen, or testing was like afterthought. And when we have a waterfall method, but with Agile and Scrum, testing becomes the first class citizen of all that because people understood the importance of it. Same way as, having a sort of an coding agent will not solve the problems. Uh, you have to have a sort of we used to call it in our circle, like, shift left testing, like go to left side, like where you are requirements and code, because finding the bug over there is much easier and less expensive to fix than perhaps finding it in production. But now with AI agents, you really, really can't afford to have shift left only. It's a shift everywhere. You have to embed your quality in every aspect of your requirement generation, coding, source code, production incident. You need a system that looks at all the data artifacts that is changing all the time from a QA lens and identify, like it's like a a binocular or something, or a magnifying glass, right? Where it can see things, what's happening, and then flag the issues in real time. Anyone can find the issues once you ship a product. Your customers can find it, but you don't want to do it, right? Keep your company afloat. So you need to have a culture of QA that is not sort of separate from the main, from the way the things are being developed today. So a PM can be a coder, a quality engineer. A tester can be a quality engineer. Of course, a developer can be a quality engineer. Because the fun thing is that with MCP and with platform like OrangePro, you can literally talk to a QA bot and identify the issues beforehand, because you can just literally type anything that you want uh, to ask, and the system can look at the code and provide you very English language sort of a mechanism to identify the problem. So tool is not the solution here, is the overall culture that we need to fix.
But yeah, I got what you're saying. I think amazing having this conversation with you. I really liked the way we've went through this. I really loved the conversation. And thanks for sharing those insights. And thanks for your time.
Thank you so much, Raghu. Thank you for your time. Appreciate that.
Aamir, thank you for joining XTrawAI and for sharing such a fascinating perspective on how frontier AI models and deterministic risk mapping can work together to build better, safer software. And thank you to everyone listening. This episode officially kicks off season 20 of XTrawAI, and we have many more exciting conversations ahead as we explore where AI, enterprise technology, and innovation are heading next. So stay tuned, stay curious, and keep extracting the raw AI. I'm Raghu Banda. Until next time, happy predicting the future with XTrawAI.